In early 2025, a satellite aimed at the Giza plateau returned images that a team of researchers at the University of Pisa did not expect to find. Beneath the three pyramids, beneath 4,500 years of excavation, exploration, and archaeology, synthetic aperture radar resolved a network of structures extending more than 600 meters into the bedrock of the Egyptian desert. 8 vertical shafts, each plunging approximately 640 meters downward, spiraling as they descend, connecting at their base to 2 massive chambers estimated at 80 meters across each. The underground complex spans an estimated 2 kilometers beneath the plateau. No civilization in the ancient world is supposed to have built anything like it. The Egyptian Ministry of Antiquities acknowledged the findings, but has declined to confirm them. The cameras and ground-penetrating instruments aimed at that desert floor for over a century never found them, until a satellite looked down from orbit in the right frequency of light. And the plateau revealed something it had been holding for 4,500 years. The mainstream version of the pyramids is the version most people carry with them. A pharaoh, a workforce, 20 years, the tallest structure in human history, built as a tomb. That version is supported by genuine archaeology. It is also, almost certainly, just a fraction of the full story. And the closer science looks, the more the gap between what we were told and what the instruments are finding refuses to close. The Great Pyramid of Giza is attributed by the mainstream of archaeological scholarship to the pharaoh Khufu, a ruler of the 4th dynasty dated by convention to approximately 2589 to 2566 BC. On that accepted timeline, the structure is roughly 4,500 years old, the product of a state that mobilized tens of thousands of skilled workers, quarried 2.3 million stone blocks, averaging 2.5 metric tons each, and raised the tallest structure in human history within an estimated 20 years. That version of events is supported by genuine evidence, most notably the Merer Papyrus, the oldest papyrus scroll ever discovered, written by an Egyptian official who recorded the logistics of transporting limestone from the quarry at Tura to the Giza plateau by barge. It is a foundation built from real archaeology. It is also, almost certainly, incomplete. The age question does not begin inside the pyramid. It begins on the body of the Great Sphinx. In the early 1990s, geologist Robert Schoch of Boston University conducted a structural examination of the weathering patterns visible on the Sphinx's enclosure walls, the limestone cut directly from the plateau during the statue's construction. The erosion he found carries the signature of prolonged water weathering, deep, vertical channels running down the face of exposed limestone, produced by sustained rainfall rather than the horizontal wind erosion that defines a desert environment. The last time Egypt experienced rainfall intense and sustained enough to produce that level of weathering was the African humid period, a climatic window that closed somewhere between 7,000 and 10,000 years ago, thousands of years before the civilization that supposedly built the Sphinx is said to have existed. Schoch presented his findings to the Geological Society of America and stated his conclusion directly. The Sphinx and its enclosure may predate the first dynasty of Egypt by several millennia. The Egyptological establishment has contested that conclusion for 30 years, without closing the debate. What has shifted is the scientific context surrounding it. Satellite imaging of the Giza plateau has revealed ancient river channels and drainage systems beneath the surface, suggesting that ancient Egypt's geological record is far more complex than surface observation indicated. Ground-penetrating radar surveys of the Sphinx enclosure have returned anomalous signals in the bedrock below the statue, signals interpreted by multiple independent research teams as evidence of structural irregularities that have never been excavated. The age of the Giza complex is presented as settled fact in most textbooks. In the peer-reviewed literature, however, the conversation has remained open for 30 years and is showing no signs of closing. The structure also speaks to something beyond the engineering problem. Long before the first block was quarried from the limestone beds at Tura or the granite cliffs at Aswan, someone mapped the night sky above the Giza plateau with a precision that does not reconcile easily with the instruments available to a Bronze Age civilization. The Great Pyramid's 4 faces orient to true north, south, east, and west, with a deviation of 1/15 of a single degree, a tolerance that approaches the theoretical limits of modern GPS-assisted surveying. The shaft ascending from the king's chamber, cut at an angle of exactly 32 degrees through more than 70 meters of solid stone, was aligned in the epoch of construction directly at Thuban, the northern pole star of the Old Kingdom, the fixed celestial point around which the entire visible sky revolved. The shaft rising from the Queen's chamber was angled, on the same celestial geometry, toward the belt of Orion, called Sa by the ancient Egyptians, the stellar body of Osiris, sovereign of the afterlife. The precision of those alignments, maintained through solid masonry across the full width of the structure, exceeds what a coincidence can account for. In 1994, Robert Bouval and Adrian Gilbert advanced a proposal that the plateau's layout carries the same celestial logic at the scale of the landscape itself. The 3 pyramids of Giza, the Great Pyramid, the Pyramid of Khafra, and the smaller Pyramid of Menkaure, mirror in plain view the 3 stars of Orion's belt as they appeared above Egypt's horizon in approximately 10,500 BC. The Nile, running beside the plateau on the same terrestrial map, mirrors the Milky Way running alongside Orion on the same celestial map. The Orion correlation theory has generated sustained academic friction, contested on the precision of the alignment and the implications of the date it implies. What has proved resistant to that friction is the physical relationship itself. The 3 pyramids are unequally spaced and unequally sized. The smallest, Menkaure, is offset to the left of the axis defined by the other 2, precisely as the leftmost star of Orion's belt is offset from the axis defined by Alnitak and Alnilam. The geometry of the plateau matches the geometry of the sky. Whether that match was engineered deliberately, arrived at through a process science has not yet fully identified, or represents a correlation that is genuinely coincidental, the relationship is real, it is documented, and the academic community has not agreed on what it means. Beneath the surface of the Giza plateau, the instruments of the 21st century are finding things the accepted narrative did not predict, and the most extraordinary findings came in 2025. A research team led by Professor Corrado Malanga of the University of Pisa and Dr. Filippo Biondi of the University of Strathclyde deployed synthetic aperture radar, a satellite-based imaging technology capable of penetrating deep into solid ground across the full extent of the Giza plateau. What they reported in early 2025 has divided the scientific community and generated a level of debate not seen since the Scan Pyramids project confirmed the void above the Grand Gallery in 2017. Beneath the 3 major pyramids, the radar data resolved a network of structures extending far deeper than any previously recorded anomaly at the site. 8 large, cylindrical vertical shafts, each estimated at approximately 640 meters in depth, plunging more than half a kilometer into the bedrock of the Egyptian desert. Each shaft, according to the team's analysis, is wrapped in a spiraling ramp or helical passage descending its full length in a corkscrew pattern. At the base of these shafts, the radar images show 2 massive cubic chambers, each estimated at approximately 80 meters across, connected by the spiral pathways above them. The entire underground complex spans an estimated 2 kilometers beneath the plateau. The Egyptian Ministry of Antiquities has acknowledged the findings without confirming them. Mainstream Egyptologists have challenged the methodology, questioning whether SAR can produce reliable structural data at those depths. The research team stands by its analysis. The structures have not been excavated. Whatever they represent, whether architectural reality or imaging artifact, the instruments found something, and the scientific community has not yet agreed on what it is. Set the underground question aside, and the problem of construction itself remains the deepest mystery of all. The precision achieved at the surface of the Great Pyramid is the detail that silences engineers. The casing stones that once covered the pyramid's exterior were fitted together with joints averaging 0.5 millimeters in thickness, a tolerance so fine that a sheet of modern paper cannot be inserted between them. That level of fit was achieved across an exterior surface of more than 5.3 hectares, on a structure rising 146 meters, aligned to the cardinal directions within 1/15th of a degree. The base of the Great Pyramid deviates from a perfect level by less than 2 centimeters across an area the size of several city blocks. Multiple structural engineers have stated publicly that they would struggle to replicate that standard today with the full resources of modern construction technology. The question of how the builders achieved it has never been answered to universal satisfaction. The precision described above is the result. The mechanism by which 2.3 million blocks, averaging 2.5 metric tons each, with individual granite ceiling beams in the King's Chamber reaching 70 tons, were raised to a final height of 146 meters, with the tolerances the finished structure demonstrates, remains a problem that no single model has resolved to universal satisfaction. The dominant academic model holds that the blocks were transported on wooden sledges hauled across wetted sand and elevated to progressively higher courses on external ramps of compacted rubble and gypsum mortar. The Marais papyrus confirms the barge logistics of limestone transport from Tura. Experimental archaeology has demonstrated the sledge mechanics with material confidence. Water applied to sand in front of a loaded sledge reduces friction by a factor sufficient to account for the transport load, and a ramp system using wooden posts and rope channels discovered at Hatnub in 2017 demonstrated a credible mechanism for raising extremely heavy blocks up steep inclines at a quarry face. For the lower courses of the structure, the external ramp model retains the strongest evidential support among mainstream Egyptologists. The upper courses do not resolve as cleanly. An external ramp capable of servicing the pyramid's full height would need to extend approximately 1.6 kilometers from the structure's base, and its total volume of construction material would approach or exceed the volume of the pyramid itself. No evidence of that ramp's base footprint has been located on the plateau. No quarry spoil consistent with its mass has been identified in the surrounding archaeological record. French architect Jean-Pierre Houdin proposed in 2007 that the upper courses were raised using an internal spiral ramp running immediately inside the pyramid's outer casing, a continuous ascending passage that solved the volume problem by eliminating the external structure entirely. His model produced structurally plausible results, generating genuine interest from structural engineers. The Egyptian government has not granted permission for the interior scanning that would confirm or eliminate the internal ramp's presence. The blocks are in place at 146 meters. The mechanism that raised them to that elevation, at the tolerances the structure demands, has not been proven. The hardness of the materials involved deepens the problem considerably. Granite, the stone used for the interior chambers of the Great Pyramid and transported more than 800 kilometers from the quarries at Aswan, registers between 6 and 7 on the Mohs hardness scale. Diorite, used extensively for statuary and ceremonial objects across the Old Kingdom, registers between 7 and 8, harder than iron and harder than almost any material available to a Bronze Age civilization. The tools the Egyptians demonstrably possessed, copper chisels and saws later supplemented by bronze, register at 3 to 4 on the same scale. By the fundamental physics of material interaction, a softer tool cannot cut a harder stone without an intermediary. Experimental archaeology suggests that abrasive compounds, quartz sand, corundum, inserted between the tool and the stone could bridge that gap, and there is archaeological evidence for their use. But the engineering challenge does not fully resolve. In the 1880s, the British Egyptologist Flinders Petrie examined granite drill cores recovered from quarry sites at Giza and identified a spiral groove in the stone that indicated the drill had advanced approximately 1 millimeter per full revolution of the tool. A penetration rate that Petrie himself noted was far higher than copper tools applied with quartz abrasive should theoretically achieve. What produced that rate of penetration, and what the full drilling apparatus looked like, has not been conclusively determined. But somehow the stones were cut, and the method by which they were cut at that precision and at that scale remains open. Among the most discussed and contested artifacts in the entire material record of ancient Egypt are not the pyramids themselves, but the stone vessels found in extraordinary numbers beneath the step pyramid at Sakara, and in collections and museum storerooms across the world. Excavations beneath the Sakara complex recovered more than 40,000 stone vessels spanning the early dynastic period and Old Kingdom, carved from granite, diorite, basalt, schist, and alabaster. What has drawn sustained attention from engineers and researchers over the past decade is not their quantity, but their geometry. A subset of these vessels, particularly those carved from hard igneous stone, display internal profiles whose thinness and regularity have prompted serious debate about the manufacturing methods involved. Some examples feature walls measured in single-digit millimeters, curved internal geometries with consistent wall thickness across their full depth, and surface finishes on internal surfaces that would require a rotating tool capable of operating within confined spaces. Structured light scanning conducted on multiple vessels has produced measurements that different analysts have interpreted in sharply contrasting ways. Some arguing that the consistency observed represents a level of rotational precision implying advanced tooling. Others publishing peer-reviewed responses arguing that the deviations present are consistent with skilled hand craftsmanship at the upper limit of human capability. What the debate confirms, regardless of where the precision argument ultimately settles, is that these objects were produced from some of the hardest stone available in the ancient world, in forms that most practicing craftspeople today would describe as extraordinarily demanding, by a civilization whose known tool inventory does not obviously account for the finished result. How they were made, in the volumes in which they appear, has not been explained to the satisfaction of everyone examining the evidence. The question of purpose of the pyramids carries its own unresolved weight. The mainstream answer is direct. The pyramid was a royal tomb, built to house the body of Khufu for eternity, and to anchor his soul to the cosmos through the astronomical alignments built into its design. That answer is consistent with Egyptian theology and supported by comparative evidence from other royal burial contexts. And still, the Great Pyramid of Giza, the most precisely engineered, most architecturally complex pyramid ever constructed, has never yielded a confirmed burial. Not a body, not a single fragment of human bone, not an inscription naming the dead king whose eternal home it was supposedly built to be. The king's chamber, positioned on the 50th course of the pyramid's masonry at a height of approximately 46 meters above the desert floor, contains a single object, a lidless, undecorated box carved from a single block of red Aswan granite. No inscriptions, no spells, no royal cartouches of the kind found in virtually every other burial context in 3,000 years of Egyptian funerary tradition. When Arab scholars forced entry in 820 AD, the earliest documented interior breach, they found nothing. Their recorded disappointment has survived in the historical sources. What the chamber was built to receive, and whether it ever received it, remains unanswered. But the object itself, the box that sits alone in that chamber, poses questions that the mainstream narrative has never fully resolved. And they begin with a deceptively simple observation. The ascending passage that leads from the pyramid's entrance toward the king's chamber measures approximately 1 meter in width. The granite box measures approximately 1.05 meters wide on its exterior. The conclusion was drawn explicitly by the British Egyptologist Flinders Petrie, who surveyed the pyramid in exhaustive detail in 1883 and stated it directly in his published findings. The coffer cannot have been brought into the pyramid after the king's chamber was finished. It is too large to pass through the passages. The box was placed inside the pyramid during the course of its construction, meaning it was not an object deposited in a completed tomb, but an element designed into the structure from the beginning, before the chamber around it was sealed and the pyramid above it was raised. The Great Pyramid was built around this box. The material it was carved from compounds the problem. Red Aswan granite registers between 6 and 7 on the Mohs hardness scale, the same class of stone used for the king's chamber walls and ceiling beams, transported more than 800 kilometers from the quarry at Aswan. The copper and bronze tools the Egyptians demonstrably possessed register at 3 to 4 on the same scale. Hollowing a box of those dimensions from a single block of material harder than the tools available to cut it, removing an interior volume of stone while leaving walls of consistent thickness on all 4 sides, is, by the physics of material interaction, an extraordinary undertaking. And the precision of the finished result makes the manufacturing question considerably more difficult. Flinders Petrie's measurements of the interior produced a finding that researchers have continued to examine in the century since. The internal volume of the box is almost exactly half of its total exterior volume, a ratio measured at approximately 1.998. Achieved with a consistency across all internal surfaces that implies a controlled, repeatable process rather than hand-worked estimation. The walls are thin relative to the overall block, ground smooth on the interior to a finish that runs uniform across surfaces a standard tool cannot easily reach. Whatever method produced those tolerances, from a block of material that hard, has not been identified in the archaeological record of the tools the Egyptians are known to have used. The box sits in its chamber, unanswered, as it has for 4,500 years. The king's chamber presents a problem that extends beyond material physics into acoustic science. Independent measurements conducted across multiple research visits to the sealed granite room have returned a consistent finding. The chamber resonates at a natural frequency falling in the range of 438 to 440 Hz, a pitch within the register of the adult human voice, and matching, within rounding error, the international concert pitch of A above middle C as standardized in modern Western musical tuning. The walls, ceiling, and floor of the chamber, constructed from Aswan granite blocks fitted to the same precision observed on the pyramid's exterior, positioned above a system of stress-relieving chambers engineered to distribute the weight of more than 2 million blocks pressing from above, produce a standing wave when struck that sustains in the sealed room with unusual clarity and duration. The reverberation profile that the chamber's dimensions generate is consistent, according to acoustic researchers who have studied it, with a deliberately engineered resonance space rather than a burial vault or a storage room. The architects who designed the coffer built it to tolerances their known tools cannot explain. Whether the same architects also designed the acoustic properties of the room around it, and whether the resonant frequency of that sealed granite chamber, 46 meters above the desert floor, was an intentional consequence of the geometry they were building, no one knows. But 500 kilometers south of Giza, an even greater mystery takes us back to the question of transporting megalithic stone. at an entirely new scale, at the Colossi of Memnon. At this scale, the engineering problem changes, pushing ramp models and sledge mechanics into a range they struggle to fully explain. On the west bank of the Nile at Luxor, two seated figures of the pharaoh Amenhotep III, known to history as the Colossi of Memnon, have watched the desert floor since approximately 1350 BC, over 3,300 years ago. Each stands 18 meters tall and weighs an estimated 720 tons. Quarried from El Gabal El Ahmar, the Red Mountain near modern Cairo, and transported 675 kilometers south to where they stand today. At that weight, the Nile could not carry them. No ancient barge could possibly bear the load. The journey had to be overland. And overland, that weight defeats every answer that ancient Egypt engineering has ever produced. A sledge over sand would bury itself, the ground compressing beneath it rather than offering the resistance needed for movement. Wooden rollers used for smaller stones would get crushed and splinter under the pressure. Any ramp capable of guiding a block of this size would need to extend across an impractically vast distance, far beyond anything the ancient world has left a trace of. The southern Colossus sharpens the problem further. It is carved from a single continuous piece of quartzite, extracted intact, transported intact, and set in position without fracture. Experimental archaeology has modeled these transport methods with blocks measured in the single-digit tons, not above 700. The gap between those experiments and the object at Luxor, between what has been demonstrated and what was achieved, is one of the deepest secrets ancient Egypt has never surrendered. The same civilization that aligned the Great Pyramid to the cardinal directions within 1/15 of a degree, and that may have engineered resonance into a sealed granite chamber 46 meters above the desert floor, placed these figures on the western bank and left no record of how it was done. And on the plateau to the north, another figure has stood at the desert's edge for longer than any of them, a monument whose age, purpose, and origins remain among the greatest unsolved mysteries of ancient Egyptian history. Beneath the Sphinx, the picture has continued to deepen. Ground-penetrating radar surveys conducted across 3 decades have consistently returned anomalous signals in the bedrock below the statue. In 2023, a research team using updated equipment reported detecting a large anomaly beneath the front paws of the Sphinx, a structure estimated at approximately 30 meters in length, located 9 meters below the surface, with geometric regularity inconsistent with natural rock formation. The Egyptian Ministry of Antiquities acknowledged the finding and indicated that further investigation was required. But as of today, the structure has not yet been confirmed. Whatever is beneath the paws of the world's oldest monumental sculpture, it has not been identified. And then there is the Sphinx itself, or rather, the question of whether the one that stands above the desert floor was ever meant to stand alone. The idea of a second Sphinx at Giza has circulated in Egyptological circles for decades. Egyptologist Bassam el-Shamar raised it years ago, citing ancient Egyptian records describing imagery that implied a mirrored monument. But it was a physical artifact sitting directly in front of the existing Sphinx that has always carried the most provocative suggestion. The Dream Stele, a granite slab installed by Pharaoh Thutmose IV around 1401 BC to commemorate a vision he claimed to have received while sleeping in the Sphinx's shadow, is carved at its apex with a pair of Sphinx figures facing one another. The conventional interpretation is symbolic. A growing number of researchers have looked at that carving and asked a more direct question. What if it was a record of what was actually there? In March 2026, radar engineer Filippo Biondi, the same researcher behind the 2025 SAR study that revealed the deep spiral shaft network beneath the Giza plateau, announced findings that have fractured the scientific community in the weeks since. Analyzing satellite radar data of the full plateau, Biondi's team identified a mound of compacted, hardened sand approximately 33 meters in height, sitting in a position of precise geometric symmetry with the existing Sphinx. The geometric lines connecting the three pyramids to the known Sphinx, when extended and mirrored across the plateau's central axis, intersect directly beneath this mound, a correlation his team describes as a precise geometrical correlation, too exact to be coincidental. Crucially, unlike the natural bedrock that would make excavation prohibitively difficult, the mound is composed of hardened, compacted sand, a material profile consistent with a buried structure rather than a natural geological feature. The existing Sphinx sits in a shallow depression below the surrounding surface. Biondi's argument is that the second Sphinx could plausibly be hidden beneath an elevated mound rather than an excavated hollow, a reversal of the same preservation logic. His team has stated they are approximately 80% confident in their interpretation and that their final full results are scheduled to be presented at a conference in Bologna in June 2026. Biondi is currently awaiting permission from Egyptian authorities to conduct ground-level investigation of the mound directly. The response from within the research community has been sharp and immediate. Dr. Zahi Hawass, the most prominent voice in Egyptian Egyptology, has dismissed the theory, arguing that extensive excavation of the area has yielded nothing consistent with a second structure. Biondi, for his part, has pushed back against critics, stating that comparisons made using standard satellite imagery lack the analytical rigor of his team's methodology, and that the experimental results gathered most recently offer a perspective that has not yet been fully presented to the scientific community. What is not in dispute is the location of the mound, the geometric relationship between that mound and the existing structures, and the fact that the dream stele, carved 2,000 years after the Sphinx was built by a pharaoh attempting to legitimize his own claim to the throne, shows too. Whether something is buried beneath that hardened sand, and whether it bears any resemblance to the guardian already standing above the desert floor, the ground itself has not confirmed. Biondi's data says, "Look there." The Egyptian authorities, who control access to that ground, have not yet agreed to look. The mound sits on the plateau, 33 meters high, in the geometry that the radar resolved, waiting. The pyramids of ancient Egypt have been studied longer than almost any other monument on Earth, and the questions surrounding them are multiplying rather than resolving. Instruments that did not exist a decade ago are returning signals from 640 meters below the desert floor that no previous generation suspected were there. Geological analyses are reopening chronological debates that mainstream scholarship considered settled. Engineers examining granite core samples from the Old Kingdom are finding penetration rates they cannot account for with known tools. And beneath the front paws of the Sphinx, 9 meters down, something geometric waits in the bedrock, found by radar, unconfirmed by excavation, and placed there, perhaps, by the same hands that raised the structures above. The ancient Greeks counted the Great Pyramid among the 7 wonders of the ancient world. Every other wonder on that list has collapsed, burned, or been reduced to fragments. The lighthouse of Alexandria crumbled. The Colossus of Rhodes fell in an earthquake less than 60 years after its completion. The Hanging Gardens, if they existed at all, left no physical trace. Of all the wonders the ancient world produced, Giza alone remains, the oldest of the 7, and the only one still standing. The civilization that built it believed eternity was worth working toward. 4,500 years later, or maybe even older, the desert is still keeping its secrets. And the deeper we look, the more it seems the builders may have wanted us to keep looking. If you think this episode was enjoyable to watch, know that we've created many more waiting to be discovered. Take a moment to explore our channel and discover another chapter of history. And If you'd like to be among the first to experience future episodes, we recommend subscribing and enabling notifications by clicking the bell icon. We release new episodes every week. If you have any thoughts or perspectives on this story, we'd be interested to hear them in the comments section down below.